In this video, we're going to go through how voltage, current, and resistance are determined differently for series versus parallel circuits, and we're going to tie that into using Ohm's law. In a series circuit, to calculate the total voltage or potential difference across the entire circuit, we add up all the individual voltages. That is to say that the total voltage is equal to V1 plus V2 plus V3 plus however many voltages we have in total. For current, it's a little bit different. In a series circuit, the current across or around the entire circuit is equal to the current at the first junction, which is equal to the current at the second junction, which is equal to the current at the third junction, and so on and so forth. So the current at any given point is equal to the current anywhere else in your entire circuit. The resistance is calculated the exact same way as the voltage. That is to say that the total resistance in the entire circuit is equal to the resistance at the first resistor plus the second resistor plus the third resistor plus however many resistors there are in the entire circuit. Remember that then we can apply all of this to using Ohm's law, which is V equals current times resistance. Let's take a look at the example here. And so this example is asking us to find the current throughout the entire circuit and to calculate the total resistance in the circuit. So what do we know? Just by what's given to us, because the voltage at the load or the battery is going to be equal to the sum of all the voltages, we don't need to do anything with that right now. So the voltage total is going to be 9 volts. The total resistance is going to be the first plus the second plus the third. So we have R1, which is 3 ohms. We have R2, which is 10 ohms. And we have R3, which is 5 ohms. Lastly, we're going to be looking for the current through the entire circuit. So to find total current, we first need RT, and then we can solve for IT. So let's start off by looking for the total resistance. So we know that that's R1 plus R2 plus R3, which is 3 ohms plus 10 ohms plus 5 ohms. That gives us a total resistance through the entire circuit of 18 ohms. We can now use that information to solve for current. The current is going to be equal to I VT over RT. What we've done is we've rearranged V equals IR. So if the total current is equal to the total voltage divided by the total resistance, that gives us 9 volts over 18 ohms and a total current of 0.5 amps. Things get a little more difficult with parallel circuits. So in this case, the total voltage across the entire circuit is not like it was in the first example. So across the entire circuit, the voltage this time is going to be equal at any given juncture. So the voltage at the first load is equal to the voltage at the second load, is equal to the voltage at the third load, etc., etc. Current is going to have switched places here with the voltage. So in this case, for a parallel circuit, the total current is equal to the current at the first juncture plus the second plus the third plus however many you have. And here's where it gets even more tricky. The resistance is actually going to be a little bit of a different function here. So instead of having RT, total resistance, equal to, what we have is the inverse of the total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus however many total resistances we have. And again, we can still use Ohm's law just like we normally would. So let's take a look here at this example and apply that resistance formula that we just looked at, because that's the one that's going to be a little bit tricky here. So we're going to do the same thing as the first example. We are going to calculate the total resistance followed by the current flowing through each resistor. So note here that we're not looking for the necessarily the total current in the circuit, because that is one more step which we can actually solve at the end. So we have a lot of things here that are given to us. Since I want the current flowing through each resistor, I also need the voltage flowing through each resistor. But luckily, since we have the total voltage, that means we know V1 and we know V2 and we know V3, and they're all going to be equal to 9 volts. So V1 would be the voltage flowing through resistor 1, V2 would be the voltage flowing through resistor 2, V3 would be the voltage flowing through resistor 3. We also have R1, which is 10 ohms, R2, which is 2 ohms, and R3, which is 1 ohm. We need RT because it asks for the total resistance. And we also need I1, I2, and I3. So we need all of these as well. So we're going to take this a little bit slower, one step at a time here. So the first thing that we're going to do is we're going to calculate the total resistance, because that's one that we can do and kind of set it off to the side and we won't need it again. So to find the total resistance, remember that that is 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Let's plug in everything we know. 1 over 10 plus 1 over 2 plus 1 over 1. Now, if you have a scientific calculator, you can plug this right in as fractions. If not, you may have to solve however works best for you, convert to decimals and solve, or convert to common denominators and solve. However, we're going to plug this straight into a graphing calculator, which is going to spit out the answer 1.6. Now, that does not mean that the total resistance is 1.6 ohms. What that means is the total resistance is going to be 1 divided by 1.6. And that's how we flip this inverse function and are able to solve for it. That gives us a total resistance of 0.625 ohms. Now we've solved that part. That's great. The next section here asks us for the current flowing through each resistor. That's actually a lot easier than you might think it is. To find the current flowing through any given resistor, all we need to do is say the current for the first resistor is just the voltage at the first resistor divided by the resistance at the first resistor. This is just a modified version of Ohm's law. So we're going to say that I1 equals V1 over R1. And we know that V1, V2, and V3 are all the same. So that's 9 over 10. That's 0.9 amps. We can do the same here for I2. That's going to be 9 divided by 2. That gives us 4.5. And we can do the same for I3. 9 divided by 1 is obviously just 9 amps. If you wanted to, you could take this one step further and solve for the total current, which would just be IT equals I1 plus I2 plus I3, which is 0.9 plus 4.5 plus 9. So 0.9 plus 4.5 plus 9 is equal to 14.4 amps. And if you wanted to verify that, we could do that using Ohm's law, because we know that V equals IR for the total system. So what that means is the total potential difference should be equal to the total current plus or times, sorry. Let's go back here. The total current multiplied by the total resistance, which would be 14.4 times 0.625. And if we are correct here, that should equal 9 volts. Thanks for watching. Make sure you like, get subscribed, leave a comment below, and check out our suggested videos. Make sure you hit the bell icon so you don't miss any future updates.